All right, let's dive right into this explainer. Today, we are decoding how a brilliantly ambitious startup named Icarus Robotics is taking the incredibly complex problem of space labor and turning it into a scalable robotic reality. And we're going to see exactly how they plan to change the way we live and work, not just up in orbit, but right here on Earth. Here's our super quick roadmap for today. We're going to hit the space labor bottleneck, the Icarus business model, embodied AI and crew safety, accelerating Earth-saving science, and finally, building better wings.
So let's kick things off with Section 1, the space labor bottleneck, and really, the sheer cost of human time.
A staggering $130,000. Just wrap your head around that for a second. That is the estimated hourly cost of astronaut time. We've got hundreds of billions of dollars of infrastructure up in space, and you absolutely need a labor force to maintain it. But at this wild price point, human labor is an incredible bottleneck. It severely caps operational revenue, and frankly, it just won't scale fast enough.
And that brings us to the core thesis of the Icarus business model. It's all about comparing that incredibly high fixed cost of human astronauts with scalable robotic helpers. Because while a robot obviously carries an upfront hardware cost, those unit numbers are continuously plummeting. The economics of replacing a $130,000 per hour human with a robot create a highly scalable, rapidly accelerating path to operational revenue.
Moving right along to Section 2, the Icarus business model and their aggressive speed to revenue. Now, traditionally, space investments carry this massive risk profile, right? You're typically looking at a grueling 6-year wait just to see your first dollar of revenue. Icarus, however, has entirely flipped the script. They've dramatically de-risked their $6 million seed round by targeting their first operational revenue in just 1.6 years. That is ridiculously fast for this industry.
So how are they hitting this aggressive timeline? Well, they're merging two completely different worlds. You've got co-founder Ethan bringing deep aerospace knowledge from NASA, and Jamie bringing cutting-edge robotics experience from Formula One. The crucial point here is that they aren't sitting around waiting to invent some perfect sci-fi level of autonomy. They are building highly practical, revenue-generating solutions today.
Which perfectly tees up Section 3, embodied AI and crew safety, are basically teaching these robots how to work.
To totally bypass the wait for that perfect autonomy, Icarus relies on something called embodied AI. Instead of just throwing around tech buzzwords, they use a pragmatic framework where human pilots control the robots in real time. This provides an incredibly strict safety net, ensuring human intelligence is literally behind the wheel immediately, all while the machines quietly learn the tasks through expert demonstration.
The whole learning process flows through this really elegant, continuous loop. The robot essentially watches a human master different dynamic perturbations of a task. And because the AI learns directly from a human's dynamic, real-time responses, the system actually generalizes. This meticulous process ensures the robot can meet the rigorous safety requirements needed to operate autonomously in a chaotic, zero-gravity environment.
But, this begs a pretty massive question. Space is completely unforgiving. How on Earth, or rather off-Earth, do you safely test these microgravity interactions before you ever put a robot next to a human astronaut? You definitely can't just wing it. These machines have to pass incredibly rigorous ground testing first.
Well, their solution is actually super clever. Over at their Brooklyn facility, they push high-pressure nitrogen through these small air bearings underneath the robotic chassis. It essentially makes the robot float, simulating 2D microgravity. This lets them do safe, rapid prototyping and rigorous safety testing without needing a multi-million-dollar rocket launch just to test how a mechanical arm moves.
All right, let's pivot to the payoff in Section 4, accelerating Earth-saving science, and what I like to call the ultimate throughput. Think about it like this. By delegating the time-consuming, mundane chores, stuff like unpacking cargo and logistics to Icarus robots, our incredibly brilliant human astronauts are suddenly freed up. This division of labor drastically increases the astronauts' experimental throughput, specifically accelerating critical pharmaceutical and scientific research that's destined for Earth. A really perfect example of this is Keytruda. A 2019 study showed that this incredibly powerful cancer therapeutic literally had its Earth manufacturing transformed because of vital research conducted up in space. Just imagine the sheer volume of life-saving discoveries we could achieve if astronauts weren't spending their precious time unpacking boxes.
And it's not just pharmaceuticals either. This massively increased throughput directly impacts things like next-generation semiconductors and advanced fiber optics.
Expanding automation in space literally unlocks multi-billion-dollar terrestrial impacts down here on Earth. It's a real game changer.
Let's wrap things up with Section 5, building better wings through measured execution.
Here's a look at their roadmap. They were founded in 2024, and like we talked about, they're already targeting rapid first revenue by 2026. And all of this measured execution leads directly to 2027, where they'll be launching the Joyride 1 mission, with the Voyager technologies heading straight to the International Space Station.
Now, Joyride 1 is all about proving this new free-flying robot architecture. The absolute ultimate safety requirement here is proving beyond a shadow of a doubt that this autonomous machine can interact without hazard within a crewed environment. It needs to operate safely side by side with human astronauts to actively save them time on orbit.
So is replacing human labor in space the ultimate ambition here? Well, yeah, for sure. But as co-founder Jamie Palmer notes with this awesome Stanley Kubrick quote about their namesake, the moral of the story wasn't necessarily that he flew too high. It was just that he should have built better wings. To unlock the cosmos for life on Earth, we literally just have to engineer better wings. So what will our world look like once those wings are fully automated? That is the question I'm going to leave you with today. Thanks so much for joining me on this explainer, and as always, keep learning.